In this video we're going to look at page 157, 158, where we're given two oblique planes and that they intersect each other. We need to find the line of intersection, and then later on we're going to find the true length of that line. So the question, as given in the book, we're given two oblique planes, VTH and V1T1H1. So I have that set up as given. So VTH and V1T1H1. Just to see what this looks like. At the moment these do not intersect, so the first thing that we need to do is we need to extend our traces until such time as they intersect each other. So this one, so they're going to intersect at this point up here. Same for the plan for horizontal traces. One extends on and the other one also. So now I have two planes that intersect each other, and if we just have a look at the SolidWorks model of that, this is the same. So I have two models that are two traces that intersect each other. This one, and so the green plane and the yellow plane. In the elevation, that looks like this. So I have one trace coming down and the other trace up here also. And then down in plan, I see the same as what I do in my own plan. The trace coming down here intersecting with the other trace coming this way. So what I'm asked to do is I'm asked to find the line of intersection between them, which will be where these two planes intersect each other. And if we look closely at it, we can see that that line of intersection starts and ends where the two traces cross each other. So my line of intersection, the red line is where my two traces up in the elevation cross, or where the two vertical traces intersect each other, and down in plan also where the two traces intersect each other. This model is available on Edmodo, so please have a look at this in your own time. Now what we need to do is we need to find what this looks like on paper. So our elevation is going to look something like this. Our line is going to be going this way, and plan, it's going to be going much the same. So if we now look at the question, we have 2 points on the line of intersection. This is 1 point in our elevation. I know where that's a point on the line of intersection. In plan I have another point, again where the two traces intersect each other. If I'm to find where the line is up in the elevation, I need to find where this point is up in the elevation. So as these are both traces, they're both sitting on the horizontal plane. So in my elevation, the view of my elevation, that point and both those traces are going to be on the XY line. So I can project my line, my point from here, finding that on the XY line and also finding it in the elevation, giving me my line of intersection in the elevation from V, where the two vertical traces intersect, to this point down here. That's the line of intersection. So I found in plan where they intersect each other and projected that up into the elevation, finding the same point in the elevation as this is down in plan. So that's the line of intersection in the elevation. In plan I'm going to do the same thing. I already have the position for it in plan. I need to find where the traces are, where the vertical traces intersect in plan, which would be somewhere on the XY line. And where is that going to be? It's going to be directly below where the vertical traces are here. So this is going to project down, giving me this point. That is the point where the two vertical traces intersect in the plan. They're on the XY line because they're on the vertical plane. So my line of intersection in plan is this line here. And that's it. That's the finding the line of intersection between two oblique planes. So just a quick recap. I have 2 points on the line of intersection already. I just need to find those corresponding points in the opposite views. So this point I have in plan, I need to locate it in the elevation, so that's going to project it straight up until it touches the XY line, because the XY line is an edge view of the horizontal plane and edge view of the traces. So that's that point. Same for this point, looking for it in plan. That's going to give me this point down here. In the second part of this, we're going to have a look at finding the true length of the line of intersection. So we have the red line here. There's a couple of different ways that it could be done. We could use an auxiliary view, project our lines off down along this way, and that would give us an auxiliary. It would give us the true length of it. So you project your lines out down along here, draw in an x1, y1 line, measure up the height of V of the vertical trace out here, and that would give us our true length line out here. Another way that we can do this, which is quite similar and works off the same idea, is if I stick a triangle in underneath my line of intersection. So the vertical edge of this here is resting up against the vertical plane. This top point will be this same point up here, and this point on my triangle will be the point down here at the bottom. So there's two ways I can do this. The first one is I just take this height and this triangle and I just flatten it down so that I can see it in plan. Then this line here would be the true length line that I'm looking for. So doing it this way, I would still be taking a line out perpendicular to my line of intersection, line coming out along this way, and I would take the height from here and swing it around until I get the same height, until it touches the line that I projected. You can always just measure the height here and mark it down. That gives it to me in plan. I can do the same idea or principle of something here in the elevation. So at the moment my line of intersection is turned something like this. The full height of it is marked up and it's coming out at a bit of an angle. What I can do is I can rotate the plane around so that it ends up being flat. So in plan what that looks like is it starts here, it's going to rotate around that vertical point and rotate around here until in my elevation I'll be seeing an edge view of the surface, an edge view of that line, a true length of that line. So just going to do both of them here. First off, in plan I'm going to take a line perpendicular to my line of intersection just from the top point. The other point is on the ground, so I don't need to do it from there. Projecting my point out, taking my compass, putting the point of the compass on this point here and measuring the height. And all I'm doing is swinging this around and that measures the height for me. So rotating that around, this giving me the same altitude as this is up here. So this line here then is the true length for the line of intersection. I can do the same thing in the elevation. I can do the other method if I want. You only need to do one of them. So in this case I'm going to be taking, I'll do it going this way, this here in plan, rotating that around until I'll be looking in perpendicular to it down, looking in that way. So this line here is also the true length of the line of intersection. I only need to do one method, I don't need to do both of them. So I can either in plan take my triangle that's underneath it and fold that down on the ground, giving me the true length of the line of intersection here, or I can do it in elevation where it's up here and I'm going to turn it around and then flatten it.